So in this video I'm going to continue the build of the B7971 SmartSockets, but I'm going to actually also include a review of this Weller WLC100 soldering station. I picked this up for $44 at my local Fry's. You can probably find it cheaper on the web. I've used Weller pencils on and off my entire career. You know, Weller makes pretty good stuff. This is an inexpensive entry point. It's temperature controlled. I do prefer a digital readout, but that adds a lot to the cost for something like this. This just seemed like a nice little entry-level pencil. I'll do some soldering with the tip that it comes with, and we'll take a look at what we think. So anyhow, first thing I want to do here is open the box up, and of course that requires me to be able to find a tool. So we'll pull this guy out of the box, assuming it'll come out of the box. Always a struggle. Shouldn't need to open. Not really sure what that's jammed up on in there. Let's pull some of the paperwork out. Well, I guess the first thing I can say is it's rather a pain to get out of the box. Nothing wrong with that. Trying to fish the... oh, come on, this is ridiculous. Trying to fish that guy out was interesting because it was... the hook on it was caught up in the cardboard packaging. So anyhow, we have a little, it's like a registration card here, product registration. We have a little user's manual. Unpack carefully. Insert the holder. Distilled water is preferred for the sponge. Insert tool. Blah blah blah. Set control knob to 5 to heat tool up quickly. Wait 1 minute. Lower setting takes longer to reach operating temperatures. Adjust control to lower setting. Remove 2 from holder and tin tip with solder. So pretty much exactly what I would have expected. There's some instructions here on what a good solder joint looks like. The manual is in multiple languages. Anyhow, there's no surprises there. There's plenty of soldering tutorials on the web. I'm really kind of interested here in giving this pencil a try. I think in the next few weekends I'm going to be doing some basic electronics training with some friends of mine. We're going to, I think, assemble some Nixie tube clock kits together, and one of them has a very limited background in electronics. The other 2 are completely noobs but want to learn, and there's certainly nothing wrong with that. So what I can see here, so there's a power outlet here on the side. So it looks like this is just a standalone soldering pencil. I can already see, I think that tip is much larger than I would like it to be. We'll find out. So I'm assuming this would be plugged in, and it's probably about 60 watts if I remember what I read. And just use standalone, or it can be plugged into the base here. And used with the base. So I'm going to get rid of the turntable for a minute. So the base is nice and solid. Docks in and out easy. It does have just a regular line cord here, which is somewhat stiff, and I suspect not very temp resistant. If I were to do this, I would suspect pretty quickly I would melt through that insulation. It uses a pretty standard sponge to clean the tip. I can see that the sponge is slotted. I will need, of course, to add some water and expand the sponge. Sponge should be damp, not sopping wet. Let me plug the pencil in. Well, power switch works. If feels like the control pot rheostat. I don't know what it looks like internally is like, but anyhow, pretty easy out of the box. I'm also going to be using a pair of these Heiko cutters. These were like $4 at Fry's. I burn through these kind of flush cutters pretty quickly. I don't treat them very well. I believe I've actually got a pair of these I've been using that are pretty beat up. But I thought, a few dollars for a new pair of flush cutters, $44 for a soldering station. Let's see if these tools together are sufficient to put together a SmartSocket board. So with that said, I'll get everything else set up and be back. So with, I hope, all the bits and pieces here I'm going to need, we'll go through and put this together. The first thing, though, is to wake up the soldering pencil. So I've got it set on temperature 5, and I've just turned it on. And though I don't know how accurate this will be, I'm going to go ahead and try to watch the tip temperature. So it's showing 22 degrees, room temp. I can smell it starting to heat up. So because of the reflectivity of this surface, I may not be able to actually measure the temperature without using a thermocouple. And it's looking like that's going to be the case here. Or it's just climbing very slowly. I'm not sure which. I certainly smell it getting hot. I can see this cord's going to be troublesome, but that's reality. I do not expect this to be anywhere near warm enough at this point to melt solder, although actually it's gotten there pretty quickly. So I'm just going to give it a nice bath of solder here on the tip. I'll go ahead and clean it off. And I'm just going to put it back in the holder and let it kind of stabilize for a minute. And while that stabilizes, we will start the assembly of one of the boards here. Oh, it's smoking like mad. Hopefully I have this sufficiently positioned. You can see what I'm doing, and it looks like I do. Yeah, that's a smoking up treat. I'm sure the heat does not need to be all the way up at 5. That's got to be much hotter than needed. I'm going to put the temperature setting down to the mid-range, to 3, and that can just sit and cool off for a bit. I've got the pins here. I'm going to just quickly look at another board and make sure I'm putting these pins in correctly on the right side of the board, and I am. The pins get dropped down through from this side. It would be a shame to put the pins in the wrong direction, have to remove them all and flip them over. That would not be a lot of fun. And let's see if a curved pair of pliers might work better for this. And we'll just do what we've done in the previous videos, and that's drop the pin down through each one of the holes without hopefully losing it. Apologies for the noises outside. I've got the window open here in the lab, and kids and animals and things are doing their thing outside. While the pencils cool down for a minute, I'm going to check and see if it's still flowing solder, and it's still flowing solder very nicely. Set to a 3. The thing to understand with soldering like this is you want enough temperature in the tip to be able to heat up the two, the pad and the device to be soldered together and melt the solder, but you want just enough temperature to do that. If you're too hot, you can stress the component, and if you're too hot, you can lift the trace off the PC board. So the idea is to have enough heat. I really can't get the orientation here right. Idea is to have enough heat to melt the solder and get a good solder flow with the minimum dwell time being the amount of time you're in contact with the pencil to the component to be soldered. So it's kind of a balance, and a lot of people are critical about exact temperature and the exact time, and I've just never been honestly that critical about it. I comfortably solder with the tip at 350 degrees C for almost everything I do. I find that more than sufficient. Like I say, for almost everything I solder, I just leave my JBC gun or station at 350 degrees C. It's a good working temperature for me. Purists out there may be yelling at me already. I don't know if you saw what I did, but it wasn't good. I knocked two of the pins loose here by sticking a finger up underneath the board. But that's what happens. Oh, one of the pins is floating here on the bench. That's not a good thing. I bought just enough with a couple extra to be able to build these all out. So, let me get all the pins back into the container here. Get it sealed up so I don't lose them. Find the roll of Kapton tape. This is the same process we used before. I'll tape them down, flip the board over, solder from the other side. I'm using the Kapton tape because it handles the heat very well. There's a lot of tape to not cover very many pins. And of course the tape fell back down onto the roll. Now I get to dig at it and start it again. I would not want to use any kind of regular tape for this because the tape will of course melt. The glue will do who knows what on the tape due to the heat. I'm sure it'll leave residue and lots of things you don't want behind. So if you're going to use tape like this, where the tape is actually touching the surfaces to be soldered, spend the money and get the right. Oh boy, gotta quit talking here while I do this. I actually picked one of the pins up out of the socket accidentally. I think all the pins are captive. That one there isn't as captive as I'd like. It's only partially covered in tape. I think at this point the pins are all sufficiently in place. I'm going to get rid of the vise, the turntable, and I'm going to put down a heat resistive surface to solder on. This is, I think, a man-made cast, stone-like material of some kind. Let me take a peek here for centering and just make sure we're somewhat in the field of view. I'm going to come back around now to the pencil and just see what we've got heat-wise. I can see there's a nice solder's nice and wet on the tip. I'm trying to actually unkink the cord here with the pencil. I've taken the heat down to 2 at this point. So I only want to be as hot as I need to be. And that feels a little sluggish melting. I'm going to go to 2.5. Give it a second here to remelt. That to me feels like it's doing a good job. So I am set at 2.5 on the Weller pencil. We'll go ahead and see what happens with one of these. I don't think I have the heat high enough. Honestly, the dwell time was too long there. It didn't flow really well. So I'm going to bring the heat up to 3. Give it a second to warm up here. And I'll touch one more pin. That's a little better. Personally, I find this tip rather large and obnoxious for what I'm trying to do. I may have to order some smaller tips for these. Okay, I'm feeling like here the heat may still be a little bit low. I have no idea if the IR... No, it still shows room temp. The reflectivity of the tip just doesn't let the infrared thermometer measure it. Just flip this over and take a look. It looks okay on that side. I'm going to bring the heat up to about 3.25. It just feels like it's a little sluggish. Well, 3.25, it might be okay. I might even come up a little bit higher on the setting there. I'm using a high quality triple core solder here. You know, the tip doesn't seem to be getting dirty, so you know, the two surfaces I am soldering here are clean. Still, you want to clean your tip pretty regularly. I am using the sponge that came with the pencil to clean the tip. I'm trying to avoid using the brass cleaning that I prefer. Trying to do this very much as you would if you had just bought this soldering station. Well, my dwell time doesn't feel bad here. I'm getting, you know, the solder joints look as good or as bad as they did with the JBC. I'm not pleased with how these are soldering, and wasn't pleased with the JBCs either. They're a little dull. I don't know if that's just me. If I could use a bit more dwell time, if, you know, I don't know. I've actually got Kapton tape wrapped around here. I'm going to have to peel that back. Well, you know, compared to the just handheld all-in-one pencils that I used as a kid, and honestly into my 20s, and God, maybe even into my 30s, excuse my swearing there, you know, this is fine. I'm certainly able to solder with it. It doesn't look horrible. Hopefully I don't have lots of solder leak through and plugging up the pinholes, and I don't. And that looks as reasonable as it did with the JBC pencil. Now the size of that tip concerns me a bit. You know, this IC socket's on 0.1 inch spacing. That's a pretty large tip. And you know, it may be absolutely fine. Oh, that didn't seat the way I wanted it to. This is blue painter's tape. The blue painter's tape works well because it releases and doesn't leave any residual behind. You get my better glasses on here to get a little closer look at this, and we'll see what kind of luck I have with these pins. I feel like that tip is really large. Really large. Tack two of the corners of the socket down. I can see the sockets in flush. Let me see if I can walk along here. In this case, I'm using a corner, a tip down here, that tip, to touch the pad and the lead. You know, this is doing a very adequate job. I've said it about 10 times, I'll say it again. I think a smaller tip would make this a more useful soldering station. I'm still at 3 1/4 on the setting dial, and I'm happy with the amount of dwell time I need to use here. I don't think it's too hot. I may actually take the temperature back down to 3 here, simply because I'm not trying to heat these large pins kind of stuff. I probably should have this in the vise to do this soldering. You're not going to potentially have a vise, although you may have a helping hand kind of set up to hold the board stationary, which does make things easier. You can see the board rocking here. I felt like I got it pretty controlled. Solder there. They, to me, look pretty consistent. I don't see anything that's absolutely horrible. I think at this point we can jump into the 33 K Ohm resistors and see what it's like to solder in some resistors. Let me find the 33s here. 33K, back in the bag from the last time I used them so they don't get confused. I believe I need 15 of them total. There's 3, 6, 9, 12, maybe even a few more than 15, but we'll start with 15. And this is a case where I'm going to go back to the vise to do this. You know, the focus here is on the using the Weller station to do the soldering. That locked in, it doesn't look to me. See if I can get that at a point where it's not too hard on your eye to look at. I will drop these in. Why does that seem wrong? 33 Ks. No, that's correct. I'll look at one of the other boards just to make sure I'm being consistent. Yes. Actually, I'm going to reverse this for what I'm doing here. This is actually going to be a little bit tricky to pull off. And I can tell I don't have the correct set of glasses on. I wonder where the correct set of glasses are. Now that I'm wearing these, they aren't providing me enough magnification. I don't believe this is them. So many pairs of glasses. Nope. I never have the pair I need. There we go. These just happen to be filthy. Oh yeah, that's better. I'm at about maybe 6 inches focal length here. Now, I'm not going to take you through the entire soldering of this board. I think that would be rather obnoxious. But I will go through the major sets of components here. We've looked at the socket. We'll look at these resistors. Maybe we'll build this side of the board up first. So we go through installing the transistors. So that's a full range of 33K. In that row, I'm going to use the blue painter's tape again to just hold those in place. I'll flip the board over. And here comes the real test to me. Yeah, that line cord's a bit obnoxious. Can I manage to successfully solder these resistors? I've got a sea of pins here. I mean, if you were doing this one resistor at a time, it'd probably be easier. I feel like I'm touching the IC pins with that big old tip. So I'm trying to change the angle here so that I'm only hitting the resistor. You know, it's doable. I think this large tip might actually make this more difficult for somebody who's new to soldering, especially on a project like this, although this probably is not an example of a good beginner project. You know, those went in okay. I'm going to grab the fresh set of flush cutters, and we will try to trim these leads where you can see what I'm doing. Trimming the soldered set of leads will make it easier to work the solder and pencil in there. And we'll just do the same thing, kind of the corner of the tip. Got a nice flow there, corner of the tip. I'm trying to avoid touching the pads that don't have components in them yet, otherwise I'll have to clear solder out of the hole to get the component lead in. And that's always kind of a pain. I keep getting in the way of the light. I know my hands are in the way of you watching here. It's not horrible. It's not beautiful. Looks like I need 1, 2, 3, 4, 5, 6, 7, 8 transistors. Let me put the 330K or the 33 K Ohm resistors back in their bag. I'll just leave the others that I removed from the carrier strip just kind of laying back here. We'll 2, 3, 4, 5, 6, 7, 8. And I'll follow the same process I followed before. The transistors I bought them have the leads all in line, and I actually need to take the center pin and offset it back into a little triangle shape to fit the outline of the board here. And it's pretty easy to just do what I just did there. Grab the pin somewhat low and just kind of rock it back and approximate the spacing of those 3 holes. You get it pretty close. I was about to say it'll drop in fairly easy, and of course it's not going in easy, but I'll just follow this same little process. I think in the previous video you saw me try some other things like cutting the center pin short and things. In assembling these, this for me has been the easiest approach. Ooh, I don't like that. I bent that one back too far, and I felt the lead kind of tear up against the package of the device, so I'm going to replace that with a fresh transistor. Last thing I need is a transistor lead failing in circuit due to vibration or age or whatever. I mean, you certainly would not want to use the process I'm using here to put together electronics to, for aerospace or anything like that. Kind of assembly is much more sophisticated than what I'm doing here. This is very much just a hobbyist build. Nobody's life is on the line if my clock fails. At least better not be. So I've got all 8 of the transistors in place. Get some tape on here just to kind of keep them flush. And the approach to soldering here is going to be the row of pins closest to my hand this way, trim them off. The center set of pins, which are the bases, trim them off. And then the inside set of pins. Of course, this is a little bit tricky because you got to work the solder down through the little sea of pins. So I believe I brought the heat down to 3. I did. This is feeling a little, well, maybe it's okay. See, it seemed like it was feeling a little too cool, but no, I think it's actually okay. What I'm having trouble with is actually making contact with the pin and the pad at the same time with this rather large tip. Of course, my big old fingers keep getting in the way, so you can't see what I'm doing. Blow out of there. We'll come through and hit the base pins on each one of the transistors. Dwell time felt a little long, but I think it's just me not getting good mechanical contact between the pin, or the tip of the pencil, the solder pad, and the device pin. And, you know, I believe in soldering. You want to touch both the pad and the pin to be soldered so that you heat both up. I've seen other people recommend against that. Been soldering that way since I was a child, since the early 70s, so for a long time. And for me personally, it's never caused a problem that I know of. But again, I'm not soldering for aerospace or medical or anything like that. I'm simply soldering as a hobbyist. I am going to recommend, I think that's probably an 1/8 inch tip on there, maybe even 3/16. And I am going to recommend, if you pick up one of these pencils, that you buy a smaller tip. I do prefer a flat tip. It's not called a shovel tip, but a bevel tip like this. And that's probably 3/16, and that's just too big to me to be able to be easy to use. It's just wide enough. It touches things it shouldn't be touching. Well, got the transistors soldered in on that side. They stayed relatively square. It's not the most beautiful installation I've ever done, but it's perfectly fine. Looking at the quality of my soldering, it looks generally okay. We move on to some additional resistance. Well, that was pure brilliance, wasn't it? That did not work very well. What did I do? So let me get the transistors back in their little bag. I think those are the 33 K ohm. These are the 27K. 27, 27. I need 3 27K on this side. Oops. Would help if I didn't drop it. For this board, I am putting the tolerance band, the gold band, on the resistors I bought down. Doesn't matter if they're resistors. I'm just keeping them all consistent, just because it makes me happy to do that. So that's 22, 24. I've got this guy in the wrong place, which is why I double checked here. 27, 27. There's actually a 33 there that I might as well stuff while I'm here, since I've got some loose 33s floating around. So that would be a 22, 33, 27's in, 27, 24, 24, 22, and 27. So I am happy with that. I'm going to tape those in place as best I can, just to keep them from shifting around. Capture the board. I'll solder this outside set of pins, and then I'll come back, or I'll trim and I'll come back and we'll do the inside set. If you've watched the previous clock videos, you've seen me assemble the little switching power supply module, and I think that would actually be a little difficult with the size of that tip, although the spacing on these is pretty tight as well. Now I do have glasses on. You see me kind of not trying to capture the tip in my fingers or the piece of wire as I cut it. I do have glasses on. It is quite possible to clip the lead and have it fly off there like it shot out of a gun, and if it hits you in the eye, your eye will not appreciate it. So use appropriate safety gear or glasses. I often catch the pins in my fingers as I trim them, just to keep them from flying around the room. But just be careful. Just as I said, just clipping the pins, sometimes they just shoot off there like they're coming out of a gun. I've had them hit me in the nose and the forehead, and you know, on the lens of the glass, and go tink really loud. And so these are 22K, and there's one. So I need two 22Ks. One up here, and there's one down here, and it looks like I need two 24K. Which probably is, that's the 33K bag, or it should be the 24K bag. And two from here. place. So the little Weller base station is sitting in place okay. It is on my blue static dissipative pad. It's got rubber feet under it. It's holding its place pretty well. It is sliding around a bit here, but that's partly because it's sitting on top of junk on the bench. Having your base move around as you're trying to put the pencil in or pull the pencil out is just an irritation you don't need. If you see what I did there or not, I got a solder bridge across that resistor. I'm going to clip the leads out of there. Actually, well, I'm going to take the other 3 leads out. So this is an interesting place. Oh, I didn't mean to trim that lead out. Crud. This is an interesting place to be. I don't know how well that's showing up in camera. I've created a solder bridge right here across a single resistor, and if I heat both sides up, the resistor would just fall out. I do have the tape on the other side holding the resistor in place. I don't know that I can just simply touch and pull up and clear that out of there. Well, I was able to do that. So I was able in this case to just touch in the center and then just lift the solder up and out. The bridge, I didn't need to go in and try to vacuum it out, but it does look like it left a cold solder joint now on this side. Again, the big tip like that will make that easy to do. Well, you know, we've got a nice little assembly of that side of the board. The 2 pins are reasonable. Soldering doesn't look horrible to me. It doesn't look awesome either. You know, it's not bad. Maybe I'm being a little too hard on my hard here. I didn't trim a lot of these as flush as I would have liked to. That's not a good looking solder joint there. Which one were you? Just touch a couple of those and reflow them. You know, the little Heiko cutters are doing their thing. This is a CHP170. It's for copper wire. I tend to cut everything with these rather than just copper wire. So it's a model CHP170. I believe it was Heiko. You know, I'm not unhappy with that. The Weller pencil did its job. You've probably seen me shuffle a bit here, moving the cord around to keep the cord out of the way as I'm working. This is an inexpensive pencil, and what that means is when I stick it down into the base station, the tip doesn't cool down automatically. It stays hot, and so if you let it sit for long periods of time, you'll burn the tip up. If you think you're going to walk away for a bit and not turn the temp down or off, do what I just did, and that is bathe the tip in solder and just drop it back in. Oh, that's nice and smelly as it sits there and boils away. Anyhow, I'm going to call that good enough for this little review. I think my impression is that it's a usable little tool. I don't know what the real value for $44 is. I know you can get like Heiko digitals, at least Heiko knockoff digitals for less than $40, I believe. I believe this is a true Weller brand, and I do think Weller's a pretty good name in soldering pencils. I think Heiko's become a really good name as well, amongst others. I think having Temp Control makes a lot of sense. You know, rather than this tip just sitting here boiling off 60 watts all the time. You know, I was probably soldering with about 30 or 35 watts of energy here. For this kind of work, that was plenty. I did bring the temperature up higher for these pins where there's more thermal mass to be heated. You know, had I bought this 20 years ago on my hobbyist projects, I think I'd have been happy with it. The only thing I'm not happy with is the size of the tip. I've been known to take a file and file the tips down smaller. The problem with that is the tip is a copper core that is plated, and I don't know what the metal is plated, and you know whatever the metal is, and of course you're removing the plating when you file, and that greatly reduces the tip life. I will be looking to see if I can find a replacement tip for this, assuming that's 3/16, an eighth, or maybe even a little bit smaller. Put on the glasses and do a bit of visual side by side here. So there's the tip that I use on my JVC, and it is about a third the width. I don't know what size tip this is, but it's about a third the width of this tip, and I find that for me a good working size. So I might actually be, for me personally, I might look for a 3/16 inch tip, or a 1/16 inch tip here for this. An eighth would be better than I think this is probably 3/16, although maybe that's actually an eighth. I find the tip too large. I would be buying, or I'd be looking for a smaller tip. Other people may find this tip size perfectly adequate. I am used to working with a smaller tip. So the advantage of the larger tip is you have larger thermal mass here. So when you touch the pad and the pin, you've got more thermal mass here to transfer energy or heat to the pad and pin. With my JVC, it's got good thermal mass, but it's also very reactive. So if the tip starts to cool, it will heat up very quickly. The heating element is way out here in the tip, along in this case with the thermocouple that provides the feedback. The heating element in the Weller here is back here in this base. And so when the tip cools, it takes time for the heat that's being created here to flow back up to the tip. So the lag time here, this is going to be much longer just because of the way it's mechanically built. Where this, with the heating element right up here in the tip and the sensing, will react very quickly when the tip temperature drops, which is one of the reasons with that fine tip I can actually solder very quickly. I'd still recommend a little smaller tip, personally. Anyhow, I've yammered on long enough here. I will end this and get this video in the list of videos to be edited, and we'll talk soon. Bye.